Okay, lesson 3.3 is on rate of change and slope. So in this lesson, you will learn to use rate of change to solve problems, find the slope of a line. Okay, vocabulary includes rate of change, slope, and that's it. Okay, so we want to talk about rate of change first. So if x is the independent variable and y is the dependent variable, then the rate of change is the change in y over the change in x. Or so if we want to think about it, it's the dependent variable over the independent variable. Okay, so remember the dependent variable depends on what the independent variable is. Okay, so if we're looking at this table and they want us to use it to find the rate of change and then explain the meaning of it. So remember the equation for rate of change is the change in y over change in x. So if we're looking at this from 152 or from 76 to 152, y went up by 76. Okay, so this went up 76. From here to here, 228 minus 152 is also changing by 76. Okay, so, but then our x changed from 2 to 4, that went up 2, and then this also went up 2. So for the change in y, it went up 76 miles for every 2 hours that were driven. Okay, so 76 divided by 2 is 38. Okay, so that means that the rate of change is 38 miles per hour. Okay. Okay, this one, it was constant for both of them. We had 76 and 76 and 2 and 2, but that might not always be the case. So here, the graph to the right shows the number of US passports issued in 2002, 2004, and 2006. We want to find the rates of change for 2002 to 2004. So we'll start with this. So the rate of change is going to be the change in the dependent variable. So this is our dependent variable. So the number of passports depends on what year it was. So if we're looking at this, so it goes from, in 2002, it was at 7, and in 2004, oops, sorry, it was at 9. So from there to there, from 7 to 9, it changed by 2. So we're going to put 2 in the top. Okay, and then for the independent variable, from 2002 to 2004, it changed by 2. So 2 over 2. Okay, so 2 over 2 is 1. So it changed by 1 million per year. Oops, I don't know what that did. Okay, so that's for 2002 to 2004. But we also want to find the rate of change for 2004 to 2006. Okay, so from here to here, our dependent variable, it looks like it to be about 12. So it goes from 9 to 12. So from 9 to 12, that's a change of 3, the rate of the dependent variable over the rate the independent variable changes. So that one changes by 2 as well. So that 3 over 2 is the same thing as 1.5. So it changed by 1.5 million per year. Okay? And we kind of just explained it. So explain the meaning of the rate of change. So this means that between the years 2004 to 2006, it changed by about 1.5 per year. And then between the years 2002 and 2004, it changed by about 1 million each year, the number of passports issued. Step 3 says, how are the different rates of change shown on the graph? So if we're looking at this rate of change is slightly less steep than this rate of change. So the more steep it is, the quickly it's going to change. So this was 1, and this one was 1.5. So 1.5 is going to be a little bit steeper than 1. Okay. All right. So we want to be able to tell whether a function is linear. So a function is going to be linear if the rate it's increasing is going to change for each thing. So this goes up by 1, this goes up by 1, this goes up by 1. So if these are going up the same over here, these need to be going up by the same amount over here. So from 6 to 12 goes up by 6, 12 to 18 also goes up by 6, and 18 to 24 also goes up by 6. So because for all of these rates between each of these points, the change in y over the change in x is going to be the same. So for all of them, the rate is going to be 6, the rate of change. So if you have a constant rate of change, that means it is linear. Okay, so this one is yes, it is linear. Okay, so what about this one? So from -10 to -2, that goes up by 8. From -2 to 6, it goes up by 8. And from 6 to 14, that also goes up by 8. So from 5 to 1, that goes down by 4. From 1 to -4, that goes down by 5. And from -4 to -10, that goes down by 6. So because these are all constant, this is going to be the first part. So going from this point to this point, the rate of change is -4 over 8, which is -1/2. But for this one, -5 over 8 is not equal to -1/2. So this is not linear because it's not the same rate of change for between each point. Okay? All right, so that's rate of change. Now we want to move on to slope. So slope is basically very similar to rate of change, but we have a formula for it. If we're given coordinates, like this is x and y, we have a point here and a point here, we can use this formula, m equals y2 minus y1. So again, change in y over the change in x, x2 minus x1, which is basically what we were doing anyway. So let's try and do a problem. So I think the easiest way to do these is to label the points. So this is our first x, this is our second x. Remember in a point, it's x comma y. X is always listed first. So this is x1 and x2. So if I called this x1, that makes this y1. The numbers have to match, and you have to have x in the right spot and y in the right spot. So then this is y2. So they said the equation for slope, we call that m, is equal to y2 minus y1 over x2 minus x1. This is a formula that you're going to have memorized because you will use it a lot. So y2, we said was 5. So I put that in for y2. y1 is 2, so I get minus 2. And x2 is 5, and x1 is -3, so minus a -3. So simplifying, 5 minus 2 is 3, and 5 minus a negative becomes plus, so 5 plus 3 is 8. So my slope, m, is 3 over 8 for this one. The next one, if I want to find the slope of this, again, I'm going to label my points, x1, y1, and x2, y2. And my slope equation, m equals y2 minus y1 over x2 minus x1. Plugging in y2, I get -8. y1 is -4, so minus a -4. x2 is -2, minus x1 is -3. So 8 minus a -4, that's plus 4. So -8 plus 4 is -4. And -2 minus a -3. 2 minus a -3 is the same thing as plus 3. So -2 plus 3 is 1. So I get -4. So m equals -4. All right. This one, again, we're doing the same process, x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. y2 is 4 minus y1 is 4. x2 is 4 and x1 is negative 3. 4 minus 4 is 0, and 4 minus negative 3 is 4 plus 3, which is 7. 0 divided by 7 is 0. So in this one, m equals 0. So it has a slope of 0. Okay, and again, same thing. So find the slope of the line that passes through x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. So y2, 3, y1, negative 4. x2 is negative 2 minus x1 is also negative 2. So 4, 3 minus a negative 4 is 3 plus 4 is 7. Negative 2 minus a negative 2, that's negative 2 plus 2 is 0. Remember, you can never, ever, ever divide by 0. So if you have 0 in the bottom of this fraction, that means it is undefined. So dividing by 0 is undefined. So it's an undefined slope. We can't do it, okay? All right, so just a quick review. If you have a positive slope, so it means there's no negatives. So in this case, this one is neither. That one's negative, and our first one was positive, okay? So what they look like on a graph, a positive slope increases. So if you're moving from left to right, it's gonna be going up. A negative slope decreases. So as you go from left to right, it's gonna be going down. If you have a slope of 0, that is a horizontal line. It's gonna be a straight line, just going straight across. And an undefined slope, so remember that's when you have 0 in the denominator, that is going to be a vertical line. Okay? Okay, we can also use our formula to find a missing coordinate. So here, we don't know what r is, but we do know what our slope is. So remember, our equation for slope is m equals y2 minus y1 over x2 minus x1. So I can plug in all of the information I have. So we'll label out points x1, y1, x2, y2, and then I'm just gonna, this is my slope, so that means it's m. So I'm gonna plug in everything I know. So 1/2, y2 is 2, minus y1 is 3, x2 is r, and x1 is 6. Okay, so I can simplify this a little bit. Well, I'm gonna rewrite it. So 1/2, 2 minus 3 is negative 1 over r minus 6. I can cross multiply this, so I can say r minus 6 is equal to 2 times negative 1, which is negative 2. And then I can add 6, and then I get r is 4. So that means that this point here is 4 comma 2. So my answer, r equals 4. And that's everything for this video. So you may stop here, or you may try the practice problems.